Yeah. So hello and welcome all. Sorry, I had to record this session and I just started that. Okay. There was not a lot of programming, but lot of concepts thought in this uh, what do you call last week that like regarding sets, regarding heaps and all those things. Uh, I haven't myself gone through everything, mostly because I've not been feeling well. So I don't know the entire thing that was taught. So I'm very sorry for that. Basically I'm a little unprepared. Uh, but yes, we can just maybe go through the assignment and see if what doubts come up, and then we will try and answer them. Okay. So yeah, these all things they don't. You will start doing programs on stacks and queues a little later when we are doing in week 7, I think. Week 6 was more of just concepts regarding all these data structures. How they are implemented is in week 7, where we'll do all these trees and things like that. Trees, objects, classes are used to create all these things. So all these are data structures that you did, stacks, queues, priority queues, and all. You will have a little more linked list, for example. So these data structures allow you to store information in a more efficient manner. And for example, if you want to search for the maximum value in a list and things like that, these kind of data structures help you do that. So, but I don't think sir has introduced you to how they are constructed in the first place, which is what is done in week 7. I guess. This is just more of a uh, introduction to week 7. So maybe we'll just try and do the assignment and see what kind of questions are there. And if I'm not able to answer them now, I will surely do them next week. I'm just a little unwell. Yeah, so bear with me. So sorry for that. But okay, let's start with this thing. Given the following permutation of this thing, this is the permutation. What is the previous permutation in lexicographic order? So lexicographic is
Your
like how do you
screen
read the
is not
dictionary?
showing.
Huh?
Your screen is not visible.
Oh, okay, okay. So sorry. Yeah. So yeah, given this sort of string, okay, you have to tell me what the previous string was in lexicographic order. So what do you mean by that question? Like when you read a dictionary, everything is in order, right? In the sense like, and how is it ordered? It's ordered from the beginning of the string. For example, F is followed by next A. If not A, then B, then or C or D or E or F, G, H, I, like that. And then once you finish the second string, then you go to the second character. Then you go to the third character. So each of these characters, you start from the beginning to the end, and the all in each carrier in each position it should be alphabetically ordered and starting from the left side of the string. For example, if I tell you apple, what letter say these are not words. Okay, for example, if I say ABC, what comes before ABC in a dictionary? Okay, what comes after before ABC? It will be AAC, no? And before that AAB, and before that triple A, right? Do you get that logic? Yeah.
Okay, so we have to do for the length of this string.
Yeah. Now, given only these characters, you have to tell me what word or what string comes just before this. So first thing, tell me how do you do it? You have had this thing permutations, no? This permutations lecture in this week 6. Sorry, yeah.
Yeah.
Where is that? Somewhere. Okay, I don't know. But yeah, how do you get to that thing? You just have to start
Delete,
placing at each place whatever minimum comes before that.
delete min operation, I think.
Yeah.
Hmm.
Okay. So if you do
Hmm.
that, can you tell me?
So we'll first try to convert this array into a tree,
Yes.
and then we'll try to then we'll pick up the last element and then try to sort in that order
Yeah.
in
So the
minimum
greatest
order.
will come on top, and you go lower, lower, lower,
Hmm.
right? And
Yeah.
then when you traverse the tree, you'll get that last permutation. So you have to do this by hand. I don't have a pen and paper to do that. Yeah. For example, what will be the root of this tree?
You can show it as on MS Paint if you want.
MS Paint. Okay, let's try. I'm a little unprepared for this, mostly because it didn't have a programming and I was unwell. Okay, okay, let's see. What is the what is the can I what is the okay largest thing in that? Can you tell me? Largest character?
J, I think.
J is it? Okay. This is pretty terrible. Okay, this is supposed to be J. Okay, or maybe I'll try right now.
Hmm.
This is bad. J. Okay. Uh, delete this. Zoom work. Okay, I'll try and do this. Okay, J. Now, tell me what are the two leaves of this root. So you have to go immediate what is immediately below this. One below this and one above this. Like both should be lower than this, but the next highest values. Yeah.
IH.
I and H. So I and H will be the, and then next for I. Okay. What is lesser than and what are the two most things below I?
EF.
E. Uh,
Hello.
hello. Yes.
Is this session supposed to be regarding week 6 or week 7 content?
Week 6.
So I believe we are doing this 7th week assignment.
Okay. 1 second.
Yeah, because the content for week 7 was uploaded only yesterday.
Wait, let me have this. This is week. Oh, okay. Wait. So week 6 and week 6 quiz. Is this your week 6 quiz?
Yeah, this is the one.
Oh, so sorry. Okay. Oh, so then you haven't done trees and things. But there were. What is week 7 covered then? Okay, I've got things mixed up. Mixed up. Sorry. Week
But that
7.
question can, if we have taken the week six classes, then
Yes, that's what I thought.
yeah.
Uh, because you have done trees. Okay, but okay, don't worry. Let's not do that then because it's next week. Uh, okay, yeah, this is easy. Suppose u and v denote sets in Python. Under what condition can we guarantee u minus v minus u equal to u? Yeah, this is just set theory. You don't need to know programming also. So v minus u should be empty, no?
Yeah, the intersection could be 0.
Yeah. Or your v minus u, that is v is much smaller, v should be much smaller than u. So if whatever elements you have, if you remove all those elements that are there in v from u, v should be empty, right? So basically the set v should be the subset of the set u, right? Because you will remove all elements when u is a superset of v, right? Suppose say set v is just numbers 1 and 2 and u is numbers 1, 2 and 3. If I remove, if I want to remove 1, 2 and 3 from 1 and 2, my v will become empty, right? Yeah? Did you get that?
Uh,
But then this can be true for me and you.
No, no, no. Because if v is very big, much larger than you, say v has more elements than you, okay? Then v minus u will not be empty. For example, v is say numbers 1, 2 and 3 and u is just numbers 1 and 2. If you subtract u from v, you will get back say 1, 2, 3 minus 1 and 2 is 3, right? So it's not empty.
Yeah.
Yeah. Did you get that?
Mm.
Okay. So yeah, that's the answer for that. Suppose you and we both
uh,
did not. Yeah, tell me.
I believe we are not supposed to directly solve assignments during the
Oh,
labs interaction.
okay, okay. Then I have not actually prepared stuff for this week, but I've actually looked up material for, yeah. What do you want to do in this week then? Because I've not actually made up material uh, to explain these things. Yeah, I
Uh,
think N Queens was
I think
there.
you can discuss the concepts related to week
Can
6.
you tell us about heap?
So heap, yeah. Okay, so heap is like a tree, okay, wherein you have a root and then you have things beneath the root as leaves, and these should be smaller than the so like we are doing here uh, in our paint thing. Suppose suppose j is greater than both these, right? And then you have for I, again I has these two things, and these should be lesser than that. So it's like a heap on top of each other. So everything below a particular value is lesser than that value. So those are heaps. It's like a data structure. It's used for searching things and all, and for arranging and all those things. Maybe I can show you with a picture. Let's see. So, so if you see this, so there are different kinds of heaps actually. So they can have ascending or descending, but they all follow one rule. That is, for example, if you have a minimum heap, then your root is always the least thing, and then you have the next two values greater than that form its next two leaves, and then this for this value again you have the next two values given your data set. What are the next two immediate values that are greater? That becomes this. Okay. So suppose you had let's see this. Okay. So this is a max heap. Okay. So here, what you have to do is, let me try and maximize this. Yeah. Okay. Can you see this? You are given, say, an array of this, and you want to represent this as a max heap structure. So max heap is basically things as arranged in descending order. So what is the maximum value here? 100. Okay. 100 is here. Now, what are the two immediate values? Okay, here that are lesser than this 19 and 36, right? Okay. And then below 36, you have 25 and on. You can see that these are always lesser than the root. Okay. And then 19 is represented as 17 and 3. Below 19, you have both these are lesser than 19, and below 17, you have 2 and 7. So this is a tree. It's called a tree representation of a heap. Okay, and that can be represented in this value. So if I just give you this, you can reconstruct the tree. Okay, because 0 1 2, then these are all leaves number from left to right. I count 0 1 2 3 4 5 6 7 8, like that, and you have all these. Okay, maybe another example is, yeah, I mean, let's sorry, I've not done a lot of research on this. So this property, okay, all heaps have this property. Maximum. So for example, you're taking max heap. Okay, each root, each node has two subnodes, and these two subnodes have to be lesser than the value above. Okay, so that is a heap. One more thing about heaps is, for example, we had that other picture, no? Yeah, let's go to that big picture. You cannot have empty nodes except the ones that are at the bottom. For example, here only the bottom row can have some empty nodes. For example, 31 does not have one more extra node here. Okay, it does not have a right node. 42 and 27, these are the last things. Okay, you can't have yeah. So one second. So you can't have just here, you just can't have only one. Okay, you need to have this field also. So they are called invalid heaps or things like that. Okay, you should not have holes or cavities. You should not have missing values. But that's a minor point about heaps. But the major point is each node is either greater than or lesser than, if you say, if you want, this is a minimum heap. So the minimum value is at the top, and each value below is always greater than this value. For example, 10 is always less than 14 and 19. And then if you go further down, 42 and 27 are always greater than 19. So it always increases as you go down. Okay, this is called a heap, a tree representation of a heap. Okay, is that clear? Yeah.
Yes.
I don't know. So also, all these things are, if you see, they are filled from left to right. Did you see that? If you, for example, here. So this is, so these are, if you see, they are filled from left to right in each row. 100, then 19 and 36, then 17 and 3, then 25 and 1. You go from the left to right when you're filling in heaps. Okay, that is also one more rule that you need to apply. You will, I think, get more of this when we do tree search and things like that, binary trees and things like that. Currently not so much, but let's, okay, at least discuss the concepts in your quiz, maybe not the answers itself. Okay. Yeah, given what I've told you, which of these does not correspond to a minimum heap of the list of values? So you have to use uh, the concept that you, so start filling it from the minimum. So you have these values and you have to write them in heap form. Okay. So which of the following does not correspond to a minimum heap list of values? So you have to fill in things from left to right in each node, at each node level. Okay. So, and when you fill left to right, one of these things will be invalid. Okay. So you have to figure that out. Okay. And then this is what actually you can use for doing that. We will discuss.
Ma'am, excuse me, ma'am.
Yeah.
Will you please explain that question once?
This one. You have to
Question number
write.
3.
So yeah, question 3. You have to try and write this in heap form, like the tree that I told you. Okay,
Okay.
right. So this is a minimum heap. So the minimum value will come on top. See, 19 is on top. Okay. Then you have
Yes.
to do left and
Oh,
right. It's, you have to split and go to the next higher values. Okay. So when you do that, one of these will not be true, because always the two nodes on the bottom should be lesser than the node above, and the left and right should also be in order. For example, see, this is an order. 17 is always greater than no, this is need not be true. Yeah, this is not true for that, but everything above given two values should, so yeah, that is in a different kind of binary tree, but everything above, so if you split 19, if you go down, if you have two nodes 31 and 28, okay, both these values are greater, right,
okay.
than 19, so they are okay. Then you have to check for the next four values. Okay, and when you write
Okay.
these four values from left to right, you have to write them from left to right. You should see that whether these values are always greater than their root.
Okay.
So for example, here, no, uh, so how so this is suppose the question was like this and you're given like this, something like this. Okay, well, how do you write it? You write 100, then
Okay.
the next two values from left to right, 19 and 36, and the next four values, 17,
Okay.
3, 25, 1. Okay, you write them. Now you have to check whether these 17 and 3 are actually lesser than 19. This is called a
Okay.
max heap. Okay, and then again you fill from left to
Max.
right. This is a max heap. This is what
Okay.
you've asked in the question is minimum heap, I think. So it's the inverse. So the minimum value comes on top. Okay. Yeah, you have to see
Okay.
some of these will be invalid. Okay, you have to check for which of that. Okay, you just have to keep
Okay,
writing
ma'am.
left to right, one, then two values, then four values like that. Yeah, and start filling things from left to right always. Okay, you will get that one of these
Okay,
three
ma'am.
will be
Okay.
invalid.
Okay.
And then someone told me about this delete min. Can you, yeah. So this is useful when you're doing permutation and things like that to figure out, okay, lexicographic order and things like that. Okay. So yeah, what will happen? Can anyone tell me?
We'll delete first value and replace it with the last value, and then we'll try to.
After constructing tree,
Sorry?
we have to remove the root node
Yes.
and we have to replace the root node with the leftmost node of
Yes.
the tree,
Yes.
from bottom level.
And then again right left to right. Yeah.
And
So when you do that, you have to see what answer you get.
okay.
Okay.
Okay, ma'am. Okay, thank you.
So it's just writing trees from left to right and just following that order. This first thing two things are easy. They are just set theories. Okay. So heap is
So the
basically,
last
yeah.
question, can you please work it out?
I can't. So apparently I'm not allowed to. But I can tell you the concept. Okay. You first write this in a tree form. Okay, so 19 is the root, then 28 31 are its two leaves, then under 31 you get 31 29. Okay, then under 31 again no so under 28 you get 30 no 19 20 31. Yeah, under 28 you get 31 and 29. Okay, and then again under 31 you get 83 and 55. So like that, construct the tree. Once you construct the tree, you have to delete the topmost, that is the root, the topmost value. For example, you have to delete this. Okay, and then make this the leftmost node as the root. Okay, and then you see what you get. You just have to write that and then write that again in so again read it. So once you that node will shift, no, the tree will get slightly shifted in shape. Okay, then what you have to do is uh, read values from top to bottom and each at each level left to
Sir,
right.
sorry, I can't reach you. Can you please repeat it?
Yeah, yeah. So what you have to do once you delete the thing is make this as the node. Okay, make this as a node, rewrite your tree and read your tree from top to bottom at each level from left to right. What the answer you get is the answer of that delete minimum. Okay, just work it out.
Okay, sir.
So
Okay, thank you.
I think the video for this is uh, keeps. I think it's in set stacks and queues. This video, okay? No, it's in this. Maybe I'll show you the video and help you do it.
The other operation we need to implement in a heap is delete max. Now, one thing about a heap is that the maximum value is always because we have width.
This is delete. Okay, let's do delete max and then
Now,
you
one thing
apply the
about a
inverse
heap
delete.
is that the maximum value is
Okay?
always at the root. This is because of the heap property. You can inductively see that because each node is bigger than its children, the maximum value in the entire tree must be at the root. So we know where. On the other hand, the
So once you
must be
delete
deleted because the structural property of the heap says that we must fill the tree left to right,
yeah,
top to bottom. So
left
we're
to
going
right,
top to bottom,
bottom.
and we have run out of a value. The last node that we added was the one at the rightmost end of the bottom row, and that must go. Okay? So we have a value which is missing at the top, and we have a value at the bottom, namely 11, whose node is going to be deleted. So the strategy now is to move this value to 11 and then fix things. Right? So we first remove the 33 from the root. We remove the node containing 11, and we move the 11 to the position of the root. Now the problem with this is we have moved an arbitrary value, not the maximum value, to the top. So obviously there is going to be some problem with respect to its children. So here it turns out that 11 is bigger than 7, which is correct, but unfortunately it's smaller than 24. So to restore the property, what we do is we look at both directions, right? And we exchange it with the largest child. So suppose this had been 17 here. Okay, then we could have swapped 11 with 17 or 11 with 24. Both violations are there. But if we move the smaller child up, then 17 will not be bigger than 24. So we move the largest one. So in this case, we move 24 up. Okay? And now we have 11 again. And now we have to again check whether it is correct with respect to its two children. So again, it is not. So we move the largest one up, namely 12. And then we see now whether it is correct with respect to its children. At this point, 11 is bigger than 10. So we stop.
So did you get that? So this is an inverse of what we have to do. Okay. So this is a max heap. We have to do a minimum delete min. So this same thing will happen, that the last node will go up on the top. But now when you do left and right, we have to see the opposite. Here they have shown they have swapped it with the larger value, right? But there we have to swap it with the smaller value. Okay, smallest of the two. Okay, where it's violating that condition. Okay, is there a minimum heap? Let's see.
Similarly, children of 5 building the heap, starting with a maximum 1. So it is natural that we get into the same, we can figure out.
But see, just focus on this thing.
2 up, namely 12 children. At this point, 11, but unfortunately,
see, this is the crux part. Once you
node
move the
containing
thing on
11,
top, no? Let's see
and
what
we move the 11 to the position of the root. Now the problem with this is we have moved an arbitrary value, not the maximum value, to the top. So obviously there is going to be some problem with respect to its children.
So here it's easy because 11 and 7, this is okay. That 11 is greater than 7. Okay, but 11 is smaller than 24. Okay, so it's not the maximum value. So you need to swap. So it becomes, you can just swap 11 and 24. But what if even the right node was bigger than the number 11? For example, he shows that it's 17. Okay. So then he chooses a maximum value out of these two and swaps it with that. Again, 24 is greater than 17, so you swap 11 with 24. Now in our thing, we have the minimum value. That we are doing a minimum heap. So we have to see, for example, if this number, let me show you in Paint maybe. Okay. Delete. Let's try and okay. Okay, let's write. I'm just showing you this. What is the value of the? Suppose we are doing minimum heap, no? So 30. Okay. Then the numbers are not easily visible. Say 24. We are doing a minimum heap, so maybe 36, and then here you have 46. Okay, and then you go down. You have 10. So I'm feeling you have to always fill from left to right, top to bottom. So top to bottom, left to right in each row. 10, and maybe here I have 12. Okay. So this is my thing. So how do I represent this heap? I represent this as 30, comma 36, comma 46, 10, comma 12. Okay, this is how I write it. Now when I do a delete min, okay, what happens is this root goes off. Okay.
Ma'am, it is not min heap. No?
It is minimum heap, no? The question.
But 36 is greater than 10 and 12.
Oh, sorry. This is, sorry. Yeah. This has to be different. Oh, I can't.
So there we can put some,
some greater value.
40.
Yeah.
40
Yeah,
or
yeah.
47,
Yeah, yeah.
whatever it is.
Say I want 50 and 60. Okay.
Yeah.
60. Now, suppose I want to, so this is 50 and 60. So forget this is 50 and 60, okay? Now, I do a delete min. So what I do is I delete the thing. So when I delete the root, so let me delete this, okay? I have to transfer this on top, okay? I don't know how this works. Yeah. Oh my God. I have to transfer this here, okay? Now, this is violating both the conditions, right? It's not lesser than 36 or 46. Now, where will it go? It will go to the left because 36 is lesser than 46. So I just swapped, okay? How do I do that? Okay, you get the drift. So this will become 60 and this will become 36. Uh, very hard. Okay, let me write it. 36. Okay. Now you have to go down. Now 60 is not less than 50, right? So again, you have to swap 50 with 60. So and you'll get something. You'll get something ending with 36, 50, 46, and 60. Okay. So this is your delete min. So when you operate, so when you get the answer, it will be like this. It'll be 36, 50, 46, 60. Okay. Do you get that? Yeah. So this is what happens when you do a delete min operation for a thing of this. This is not. This is 50 and 60. So this is not. Let me delete this. So if you initially had something that was what 30, 36. What was below here? Something, no? I don't know what was there. What was the value?
46.
46, 46. And then 50, 60. So if you do a delete min to that, you get a thing that looks like this. Okay. So you have to do the same here in your question.
Sir, what if I have an extra value like 45, which is smaller than 50 and 60? That is an incomplete tree, right? What should I do in that case?
So where will you have a, so you have to fill everything from left to right, no? What is the question?
If I have 45 with this, which is lesser than 50 and 60, should I move 45 first to the top when I delete 30, or I should move the bigger one, that is 60?
You should move the the lowermost value. The rightmost value, sorry.
That
The
is 45,
rightmost.
which will be separate.
So this rightmost value, you have to remove and put it on top. For example, here initially my 60 was here, no? My 60 is my rightmost value. I put that on top. Did you get it?
Yes, sir. If I have 45 with 46, then I should move 45.
Yeah, if it's on the rightmost, yeah. If whatever is the rightmost gets moved on top. On the bottommost row, whatever is the rightmost value. For example, here 60 is my, in when I draw this tree, 60 will come at the bottom and at the rightmost value row, that will go up. And then you have to do some changes then. Okay?
Okay.
Ma'am, we tried, but we are not getting answer, exact answer. We tried it.
Maybe I'll try. I'll try it on paper. It's a little hard doing it there. I'll try. What is the question? Okay. 19. 19, then you have 28, 31. Then for 28, you have 29, 29, 83, 85. Can you switch off your mic, whoever is on? 83, 85, no, 83, 83, 55. Then 97, 97, 45, and then 72. So 72 is your last element. It's below 29, is it? Am I correct?
Yes, ma'am.
Okay, now what you have to do is move 72 on the top. Okay, delete 19.
Yes, ma'am.
Move 72 on the top. Now, you have 72 and 28 and 31. Okay, it's greater than both. Okay, so it's violating both. Then you but since 28 is lesser than 31, I will swap 22 and 72 with 28. Okay.
72 is swapped with 28.
Yes. Okay. Now 72 is greater than 31 and 29. 72 swaps with 29 because 29 is lesser than 31. You have to do the opposite of max heap basically. So it's 29 and 72. Okay. Now 72 is ended. So you have 28, 29, 31. Okay. Then you have
again 31,
31, 72, 83,
83,
55,
55,
97, and 45.
97, 45.
So you have the answer, right? You have to do the opposite of max heap.
Ma'am?
Yeah? What? Did you get the concept?
Yeah, ma'am, I get. Thank you, ma'am. Thank you.
Yes, sir. Yes. Thank you.
I'm not
What we
supposed
are
to discuss the things, but
replacing 72 with 31.
sorry?
We are replacing 72 with 31 instead of 29.
72 with no, you have to replace 72 with
replace
29
smallest
and not
one.
31. You have to replace 72 with 29 because 29 is lesser than
Yes,
31.
Yeah, okay.
In max heap, what you do is you suppose two numbers are both are smaller. If the number on top is smaller than both, then you replace it with the larger number. Here you have to do the opposite.
Okay. Okay, ma'am. Thank you, ma'am.
Okay. I think that's it for today. I don't have. Sorry, I wasn't feeling well for the most of last week, and I couldn't make up content. But next week we will, and next week is more on classes, objects, and which is more closer to programming. We'll do some programming. Okay, with respect to
Okay,
lists
ma'am.
and things like that. And yeah, this week was not a lot of programming, so I could not prepare. And yeah, both things. But please read up on these things. Mostly on, I would say, these heaps, because heaps come into. We'll do trees next week also, and there it will be useful if you have an idea of this. Yeah,
Sir,
yeah. Tell me.
sir, then for third question, we should not delete. We should just swap the lines, right?
Yeah, you should swap, not cut out. Only you have to delete at the beginning. You have to just delete the root and replace it with the rightmost value, and then just swap values.
That is for development, right, sir? I'm asking for third question. They are just asking which does not correspond to any.
You just
Then
have
we
to
should
write
just
the tree.
swap
You have to
the.
write. You have to write the tree. Okay. Write a minimum heap tree. Okay. And you will see that one of them will not be correct. What it will violate is your numbers will not be greater. Like they won't be numbers below the node will not be greater than the one on top. So you'll get that violation. For example, you'll get a node like this. For example, the root will be 20, and below you'll have something like 19 and 16. Say it's greater. So 20 is greater than both 19 and 16, which is not correct for a minimum heap. Okay. So one of these will violate that. Just write it out from left to right. You'll get this very easily. Top to bottom, left to right. That condition will be violated in one of these heaps. Okay. 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 I think if not anything else, we'll stop. And I hope to be better next class, and we'll do more. Okay.
Okay, ma'am. Thank you.
So sorry for not being content
No
wise.
problem, ma'am. Thank you.
Thank you.